Hello everybody. So some of you that are going to watch this video already saw some of this information, okay? But just so you know, there's going to be more information later on in this video that you haven't seen, so keep watching, okay? So this is how existence works, okay? On the fundamental level of existence, you have photons, Higgs bosons, and gluons, okay? So photons are basically equal to +1. Higgs bosons are basically equal to -1. Gluons are conglomerations of photons and Higgs bosons, okay? So they're equal to 0, okay? So if you want to think about it in a wave format, you have basically photons, which are the first part of the wave, and then you have Higgs bosons, which is the second part of the wave, okay? So the photons are pushing out, Higgs bosons are pulling in, okay? And then what do these make? Kind of like a yin and yang symbol, okay? Which is what? The gluon. Which is what? Infinite photons and infinite Higgs bosons, okay? So that's the wave way to look at it, okay? In case you notice, it looks kind of like a yin and yang symbol, okay? Which we are the photon, which is the light, the Higgs boson, which is the dark, okay? And both of those infinitely converged, both expanding and contracting. What do those make? They make the infinite rainbow which we live in, which is the gluon, okay? All that you see out here, all this, everything that's coming into you infinitely basically contracting into you, infinitely expanding out of you, is basically the infinite rainbow of existence that we all live in, okay? So let's get into the electromagnetic spectrum, okay? What I like to call the information spectrum, okay? So the beginning of the spectrum is basically the Higgs boson. Okay? Which is, or as you can think of it, the Higgs boson, which is infinitely large. Okay? And then from there, you have radio waves. And then from there, you have microwaves. From there, you have infrared. And then from there, you have light. And then from there, you have ultraviolet. And then from there, you have X-ray. And then from there, you have gamma. And then from there, you lead back into the Higgs boson. Okay? So within here, you have the infinitely small Higgs boson. And out here, you have the infinitely large Higgs bosons. Okay? That's basically the information spectrum. Okay? Getting infinitely smaller to infinitely larger. Okay? So that's basically the information spectrum and how it all comes together. Okay? So let's get into how existence can be both finite and infinite. Okay? So you are both finite and infinite. Okay? You basically are born, you live, you die. You're born, you live, you die. Okay? So your lifespan is finite, but your existence is infinite. Okay? That's how it is for everything within existence. Okay? Because mass is finite, but energy is infinite. Okay? So if you look at this as, okay, so think of it as the wave, okay? You have the photon and the Higgs boson, okay? Which make up what? The gluon, okay? Now, if you look at it just in a wave function way, okay, it's finite. But if you account for both particles and waves, it's infinite. Same thing with particles, okay? If you account for just particles, it's finite. But if you account for waves and particles, it's infinite, okay? Because what does this wave consist of if you break it down? Well, it consists of infinite particles, okay? You take this rope and you basically look in it, what are you going to see? You're going to see infinite Higgs bosons and infinite photons, okay? Which are infinite, okay? So if you take into mind both particles and waves, it's all infinite, okay? So let me get into relativity and quantum theory, okay? So in order for people to make things work, they have to use their imagination to basically come up with formulas to make things work, okay? Which is why we've gotten to the part of existence that we've gotten to thus far. That's why we have high-speed internet, television, electricity, all the technology that we have, because people have come up with ways to measure things, okay? So Einstein came up with relativity, which is E equals mc squared. Planck came up with quantum theory, which is E equals Planck's constant times frequency. Okay? But the thing about it is, E equals mc squared, squared is an arbitrary number. Just like Planck's constant is an arbitrary number. Because naturally within existence, everything is infinitely expanding and infinitely contracting. Okay? Meaning things are getting infinitely larger and infinitely smaller. Okay? So both of these numbers are arbitrary numbers. They just pulled out of nowhere to basically make things work. Okay? So Planck's constant is 6.626 times 10 to the negative 34th. Okay? It's just a really arbitrary small number. Okay? It's just basically the way to describe the energy within a photon. Okay? So, but everything is basically infinite. So these numbers, like I said, are just arbitrary numbers. They're just ways to basically make things work, which they've helped us out a lot. We've developed a lot of technology and things like that based off of these theories. But in reality, everything occurs naturally within existence infinitely. Okay? Just like the double slit experiment. Okay? Whenever they watch the back screen, naturally, the particles basically showed up on the screen in a wave formation. But whenever they went to measure it, they showed up in a particle formation. Well, why is that? Okay? Well, I'll explain why in a second. Okay? Because, like I said before, existence is basically made of infinite photons, Higgs bosons, and the Higgs boson, and gluons. Okay? So what are photons? Well, photons are photons, protons, and stars. Higgs bosons are basically electrons and planets, moons, and asteroids. Or no, sorry, I got that backwards. Higgs bosons are basically electrons and black holes. And gluons are basically neutrons and planets, moons, and asteroids. Okay? So, what do you consist of? Well, you consist of photons, Higgs bosons, and gluons, which are what? Protons, electrons, and neutrons, which are what? Stars, black holes, planets, moons, and asteroids. Okay? And why is that? Because you are the universe relative to you. Okay? You are the universe relative to you. Okay? So, let me get into the hydrogen atom real quick. I'll be right back. I have to draw a diagram. Okay? Okay, so basically this is a diagram of the hydrogen atom, okay? So like I said before, everything consists of infinite Higgs boson slash bosons and photon slash photons. Okay? So, at the beginning of the hydrogen atom, you have Higgs bosons, okay? Which are basically W negative bosons, okay? Basically pulling everything in, okay? And then you have photons, which are W positive bosons, pushing everything out, okay? And you put those together in an infinite conglomeration, what do they make? The gluon, which is both W negative and W positive bosons, okay? Pushing out, pulling in, making what? Zero, okay? The infinite sphere, okay? So, all the octaves that separate the different levels of the hydrogen atom are Z bosons, okay? What are Z bosons? Z bosons are basically where, okay, if you think of the sun, okay? Think of a photon, okay? At the horizon of the sun, relative to the sun, the photons are as large as they can possibly be, okay? And the Higgs bosons, relative to the horizon of the sun, are as small as they can possibly be, okay? Hence, what makes the horizon of the sun possible, okay? Basically, the horizon of the sun is basically photons relatively as large as they can be relative to the sun, and Higgs bosons as small as they can be relative to the sun, okay? That makes up the horizon of the sun, which is the Z boson, okay? All these different octaves are the Z boson, okay? And then you have the electron antineutrino, which is shooting out W negative bosons, okay? Basically, W negative bosons are basically Higgs bosons, okay? W positive bosons are basically photons, okay? So you have the electron neutrino, which is W positive bosons, the muon antineutrino, which is negative bosons, the muon neutrino, which is W positive bosons, the electron, which is W negative bosons, the positron, which is W positive bosons, the up quark, which is the anti-up quark, which is W negative bosons, the up quark, which is W positive bosons, the anti-down quark, which is W negative bosons, the down quark, which is W positive bosons, the tau antineutrino, which is W negative bosons, the tau neutrino, which is W positive bosons, the anti-strange quark, which is W negative bosons, the strange quark, which is W positive bosons, the muon, anti-muon, which is W negative bosons, the muon, which is W positive bosons, the anti-charm quark, which is W negative bosons, the charm quark, which is W positive bosons, the anti-tau quark, which is W negative bosons, the tau quark, which is W positive bosons, the anti-bottom quark, which is W negative bosons, the bottom quark, which is W positive bosons, the anti-top quark, which is W negative bosons, and the top quark, which is W positive bosons. And what do you have on the outside of that? You have the Higgs field. This is the Higgs field. And throughout this is the Higgs field, as well as this is the Higgs field, okay? And what is the Higgs field? It's infinite Higgs boson and bosons, which are W negative bosons, okay? But throughout this entire atom is infinite infinite photons and Higgs bosons, which make up what? Gluons, okay? But basically, if you want to think about it like in three-dimensional format, think about particles, which are spinning every which direction, okay? Basically making a rope, okay? Getting bigger and bigger and bigger, okay? Except in reality, instead of just going one direction, it's going infinite directions. Every which direction, okay? Infinitely expanding and infinitely contracting, okay? That is the hydrogen atom. That is existence, okay? But it's really that simple. I mean, it's basically just photons, which are light, and Higgs bosons, which are not necessarily dark, but clear, okay? For instance, let me explain relativity really quick, okay? So, relative to you right now, my hand is farther away. So relative to you, my photons are smaller. And my Higgs bosons are larger relative to you. But whenever I put my hand closer, my photons are closer to you. So my photons are relatively larger relative to you, and my Higgs bosons are relatively smaller relative to you, okay? That's how it works with all of existence, okay? For instance, right here in this room, I'm basically an energy field, okay? Interacting with other energy fields, okay? Whenever I'm walking through this room right now, I'm an energy field interacting with infinite other energy fields, okay? So, relative to me right now, photons are getting infinitely larger, infinitely smaller. Higgs bosons are getting infinitely larger, infinitely smaller, okay? That's what makes existence possible, okay? So, but it's really simple though. You know, I know existence is pretty chaotic, but it's like Leonardo da Vinci said, you know, simplicity is sophistication. You know what I mean? And all existence is basically spheres getting infinitely smaller and infinitely larger. That's a way to think about it particle-wise. But whenever you delve into those spheres, what do you see? Infinite waves. Made of what? Infinite particles. Made of what? Infinite waves. Okay? Hence why we live in infinite dimensions. Okay? We don't live in 3 dimensions. We live in infinite dimensions. Okay? So, let me get into the gradises of space, okay? I don't like to call them dimensions because then people get confused because it's been ingrained into our heads that there's only 3 dimensions which we live in. So I like to call them gradises, which in Latin means steps, okay? So it's basically the steps of space, okay? Except the steps of space are getting infinitely larger and infinitely smaller, every which direction, okay? So let me get into what the difference between dark energy and dark matter are, okay? So dark energy is pretty easy to explain, okay? Dark energy is basically Higgs bosons. Okay? Basically, the Higgs boson, as well as infinite Higgs bosons, which are infinitely large, okay, relative to us, okay? So you are here relative to your universe, which is you, okay? This is the Higgs boson, as well as infinite Higgs bosons, okay? That's dark energy, okay? Now, what is dark matter? Well, dark matter is basically where photons and Higgs bosons are infinitely expanding and infinitely contracting in equilibrium, okay? That's all dark matter is, okay? It's where they're in equilibrium. But dark energy, the photons are infinitely contracting and the Higgs bosons are infinitely expanding, okay? So let me explain how dark energy relates to you, okay? So say I eat an apple, okay? An apple is an energy field, okay? I eat that apple and I absorb it into my energy field. It goes into my gastrointestinal system and it starts to break down. Think of it as basically spheres getting larger to smaller as you basically start to ingest them. Okay? The spheres get smaller and smaller and smaller. Okay? Until they basically get to the point where they're broken down into photons and Higgs bosons. Okay? What happens to the photons? Well, they get broken down into Higgs bosons. Okay? Which basically feeds in to you. Okay? At the very bottom of the gratis. Okay? Because you're basically both the fundamental particle as well as the universal particle. Okay? Do you understand that? It's kind of hard to wrap your head around. Okay? So, to get into that a little bit more, let me explain the lithium atom. Okay? So, we've been basically taught the lithium atom is 3 protons and 3 neutrons, okay? Okay, so the protons, like I said before, basically photons, and the neutrons are basically gluons, okay? And they're surrounded by what? Electrons, okay? So they have 3 electrons surrounding them. Okay? That's the way that we've been basically taught that the atom looks, okay? But that's not really the way that the atom looks, okay? The atom looks more like this. So you have the electron, the proton, the electron, the proton, the electron, one, two, three, and the proton. Okay? So that's how the lithium atom really looks. Okay? So whenever you basically hook up an electrical device to a lithium atom, what happens? Well, think of it kind of like as a tire or like a basketball, okay? You get a knife and you stab a tire or a basketball, what happens? Well, the air basically escapes back into space, okay? Basically all it is a interchange of space, okay? And that's all that's happening within a lithium atom, okay? So as you start to drain the electrons, which the electrons are what? Electrons are infinite Higgs bosons, okay? So you have the space within the lithium atom start to deplete, okay? So it's going basically to the electrical circuit, and this one begins to run out, this one begins to run out, this one begins to run out, and they basically keep doing that until it gets to a point where, relative to the circuit, the energy is depleted, okay? And you no longer have any Higgs bosons left. It's only the photon, okay? Which is what? The proton, okay? So think about it like whenever you heat your stove up, okay? Whenever you heat your stove up and you start seeing the coils getting red, what is happening? Well, basically, let's get back into, okay, so the sun, okay, so this is the sun. Okay, so like I said before, outside of the sun you have space, which is what? Infinite Higgs bosons, okay? By the time they get to the horizon of the sun, relative to the sun, they are as small as they can be, okay? Relative to the horizon of the sun, okay? So they get smaller and smaller and smaller, basically until they get to the horizon of the sun, okay? And then what happens to them? They start to get larger again, okay? Till they get to the singularity of the sun, which is basically a black hole, okay? Which a black hole is what? It's infinite electrons, which are what? Infinite Higgs bosons, okay? So whenever you're looking at your stove, all that's happening is you're seeing basically the black holes within the photons of the metal expanding, okay? That's why they're starting to get bright red, and that's why they're starting to get very hot, okay? Because they're expanding, okay? And that's all that is. That's how dark energy relates, okay? Because all dark energy is infinite Higgs bosons, okay? there's two kinds of energy. There's dark energy, which is basically Higgs bosons, which are what? W negative bosons. And there's light energy, which are what? Photons, which are what? W positive bosons. Okay? It's that simple. That's all it is basically an exchange of space going every which direction infinitely. Okay? So, let's get into time travel. Okay? People ask a lot of time, is time travel possible? Yes, we're doing it right now. We're time traveling into the future right now. Okay? But is time travel into the past possible? Okay? Well, think about it like this. So, this is you. And this is the sun. The closer that you get to the sun, which is a photon, the faster time is going to go. Why? Well, because once you reach the horizon of that photon, you're going to burn up. That's infinity. That's as fast as time can possibly go. Okay? But that's because photons are equal to +1. Okay? Because time is moving forward. Okay? But Higgs bosons are equal to -1. Okay? So, relative to you, if you travel towards a black hole or electrons or infinite Higgs bosons, what's going to happen? Well, chasing a black hole is just like chasing a rainbow, okay? You're never going to catch it. But what's going to happen whenever you get to the horizon of where you thought the black hole should begin? Well, time is going to reverse. Okay? It's going to reverse. You're going to be going back in time. Okay? It's pretty insane, but it's cool. And you are going to be getting, relative to somebody back on Earth, you are going to be getting smaller. You're going to be getting smaller and smaller and smaller and smaller. Okay? Until you hit the horizon of where that black hole would have been, and then what happens? Time starts over again. And theoretically, you may even become younger. Okay? So let me talk about a couple things before I talk about that first. Okay? So I know a lot of people are worried about climate change, okay? I'm not that worried about climate change because if it is man-made, I'm pretty sure that we're going to solve it just down the road, okay? If we just start working on magnetic technologies and stuff like that, it's not going to be that hard to solve it, okay? If it's man-made. But the issue with it is like I said before, things have to live and things have to die, okay? There has to be love and entropy, okay? There can't be one or the other, okay? There has to be both of them, okay? So in order for love to be able to exist, entropy has to be able to exist, okay? But the issue with it is entropy can be considered the black hole in the middle of our sun that's growing every day, okay? Basically pushing out, okay? So as the black hole grows, it's like I said, it's kind of like a tire, okay? As the black hole grows within the middle of the sun is pushing out more light energy, okay? So the sun is evolving, okay? We depend on the sun to be on its current state in order for equilibrium to be able to take place and us to be able to survive. The issue with that is the dinosaurs were here, hundreds of millions of years ago, and they were here with most likely the same kind of climate. So our climate is only going to exist for a certain amount of time. So I want you to enjoy your time while you're here, but also in the back of your head, you have to have a sense of urgency that the sun is evolving. We have to develop technology to be able to transport ourselves off of the earth where there is no longer a sea and the moon and sun no longer light the sky, okay? We have to move towards that, okay? Because that's the only way that we're going to save ourselves, okay? We need to get on a spacecraft that's either really large or a lot of spacecrafts and start moving towards that black hole at the center of our galaxy, okay? Because that's the only way we're going to save ourselves, okay? So I don't want to get into this stuff too much because I don't want to scare people away, okay? But I do theoretically think that places like Stonehenge, which basically means the Great One, which is formed like this, okay, and the pyramids, which are basically formed like the Gratises, okay, is basically information for us, left from us, that were in the future, that went to the past to give us clues, okay? And I really do think those clues are in the religious texts, okay? But we just have to basically decode them to kind of figure out how to build these spacecraft and stuff like that. And I know that's way out there for a lot of people to understand, okay? But you have to keep your mind open, okay? That's how I've learned all these things. I didn't discriminate against religion, science, any of those things, okay? I learned everything that I could, and that's how I put all this stuff together, okay? And I ask you to do the same thing. Learn as much as you can, okay? because we only have a limited amount of time. Okay? So a while back they had something called the Sea Eagle simulation, which showed galaxy cluster filaments. Okay? So if you basically account for the infinite spheres, okay? So you have a solar system here, solar system here, solar system here, okay? At the center of those solar systems, you have basically the stars. Surrounded by what? Space, which is the Higgs bosons. And basically, the photons are infinitely pushing out, the Higgs bosons are infinitely pulling in, okay? And what does that make? Well, it makes the planets, moons, and asteroids that are all over the solar systems. Okay? So, whenever you basically get rid of those spheres and you start to connect things, it's kind of hard to connect them, but basically, if you start to connect everything, it looks like a big spider, okay? Which is what? Basically the filaments, okay? All that we can see out there is within the hydrogen atom. That's all that we can see. That's the extent of it, okay? Which makes sense, because what makes up everything? Hydrogen atoms, okay? So that's basically it. I'll put one last thing on you, and the only thing that you can basically assimilate this information for is because you are infinite as well as me, okay? All this is God. You are God, I am God. All this is God, okay? It's all God. There's not just some transcendent, omnipotent being. Everything is God. We are all God. Everything is God, okay? But everything, all hydrogen atoms basically consists of the universes that we see out there. All of them. Okay? And all those stars, planets, moons, asteroids, space, all they are is photons, gluons, Higgs bosons. Okay? And what are the galaxies? The galaxies are just the elementary particles. And what's beyond that? The beginning of the Higgs boson. And that's all it is. And don't get into the infinity aspect of it too much, okay? I don't want you guys losing your minds, okay? Because this is a lot to take on, and I understand that. But we have to start thinking about our future, okay? So we need to start building technology that'll carry us back in time, okay? That's one thing I want to talk about. I was trying to work on teleportation, but the thing about teleportation is they can do that with photons, because a photon relative to us is really small, okay? So it doesn't take that much energy to send a photon through a satellite to be able to do an experiment with entanglement, okay? But whenever it comes to infinite photons, Higgs bosons, gluons, okay, that's you would need basically an infinite amount of energy, okay, to be able to do that. Same thing with hydrogen fusion. That's why I'm a little bit annoyed that scientists haven't verified this information yet, because there's a lot of resources going to research and stuff like that they're wasting their time on, okay? Hydrogen fusion is a waste of time. You would basically need, to be able to create hydrogen fusion, you would basically need enough energy to basically create a black hole, okay? And do you think it's a really good idea to create a black hole on the Earth? I don't think so. You know what I mean? So you guys can pretty much drop that. But I do think that, let me show you guys this real quick. I do think that this may be the answer, though, okay? So like I said before, you have magnetic and gravitational waves, okay? So this is gravitational, okay? These are two magnets. You flip one of them 180, whew, that's magnetic, okay? So maybe if we build a spacecraft that's, I don't know, it could possibly be chemically propelled, maybe even nuclear propelled, and create it so that we kind of have okay, so it's basically propelled back here, and some way you might be able to have stages and stuff like that, but you basically have stages of magnets, series of a lot of magnets, or a really large magnet. Probably it would be better if it was a series of a lot of small magnets, but basically you get the spacecraft moving, and then you flip it all at the same time. That's going to provide you with a lot of propulsion, okay? Something else I've been working on as well is like a bike, okay? Why, whenever you ride a bike, does it hold you up? Well, centrifugal force, okay? So the tire is basically shooting out photons and Higgs bosons, okay? Hence why you can see the tire while it's moving, because it's shooting out so many photons, okay? And the Higgs bosons it's shooting out are basically pushing back. And that's what holds it up, okay? So out in space, we can probably use that to our benefit, okay? So maybe if we develop something with stages, maybe we develop something with stages getting bigger to smaller, and gyros or something like that, which are going one direction, and this one going the other direction. We could create something that would have propulsion going either that way or that way. Okay? I don't know for sure. This is just ideas that I'm throwing out there. Okay? But you have to learn as much as you can. Okay? But that's pretty much the plan. That's the way that it works. Okay? It's just basically exchange of space. Okay? That's all there is to it. If you would like, you can donate to my GoFundMe page, Magnitis Toys, Magnitis Toys. But anyway, just be kind to one another. If you believe this stuff and somebody tries to oppress you or persecute you for it, just forgive them and go along your day. You know, it is what it is. There's going to be people that are believers, and there's going to be people that are non-believers, and you know, don't judge them because they're a non-believer. That is what it is. You know what I mean? So just let this be the heaven in your mind that it is, and realize that even one photon and one Higgs boson are infinite. Okay, so just realize that. Okay, so one photon and one Higgs boson are infinite. That's how infinite it all is. Okay, so that's another thing I wanted to explain real quick is matter and antimatter. Okay, so let's think about an atom in this board. Okay, so this is an atom in this board. Okay, or no, a photon in this board. So everything within existence, which is not that photon, that is its matter. Everything else is its antimatter. Okay? That's the way it works. Okay? Everything within existence, which is not that photon's matter, is its antimatter. Okay? That's the way that it works. Okay? So we also need to try to work on maybe developing cloaking technology. Okay? So we can be places that people can't see us. Okay? Or entities can't see us. Okay? It's like I said, I think the religious texts are kind of like instruction manuals for us, you know. And you can say basically, well, how did this all start? That's something we'll never know. That's an answer we'll probably never know. How did it all start? You might say, well, if in the future we're going to go back to the past and basically initiate the future again, how did that start in the beginning? I don't know. Existence is infinite. I can't answer that. You know? And the question as to why do we exist? Answer to that, why not? So, you know, we had a choice. It was infinity or nothing. And we all chose infinity. Okay? So we're here for the long haul. Yeah, that's pretty much it. 0 is infinity. And how is 0 infinity? Well, because if you spin 0 every which direction, it makes a sphere. Which is what a sphere? What is a sphere? infinity. And what is existence? Existence is infinite spheres. Basically a wormhole of time going every which direction. You're a wormhole. This board is a wormhole. This wall is a wormhole. The hydrogen atoms surrounding us are wormholes. It's all wormholes of time, pushing out time, pulling in time within infinite directions. Okay? This is particle. Break these down into waves. They're waves. Break those waves down into particles. Those in the waves, particles, waves. It's infinite. It's all infinite. And that is existence. All right? So that's pretty much it. Thank you for your time. Be kind to one another. Thank you.